So welcome back. We are moving steadily. This is our lesson 6. We are talking trigonometry really, and we have seriously given it enough justice. We have given it enough justice because we are moving. We have looked at the maximum or minimum values of a function, or maximum or minimum values of sine theta and cosine theta being our functions. Now, there are some rules we follow when determining the maximum or minimum. For example, rule number 1, the maximum of the sum, this one is the maximum of A plus the maximum of B. Roman 2, the minimum of maximum, still maximum of A minus B. This is the maximum of A, that is the maximum of A minus the minimum of B. If we are talking about the minimum of A minus B, no, it is a plus. Let's start with a plus. This is the minimum of A plus the minimum of B. If we are talking about the minimum of A minus B, we minimize A and maximize B. Okay? Roman 5, we have the maximum of the product. Maximum of, this is a minus, maximum of A times B. This one is the maximum of A times the maximum of B. Roman 6, which is the minimum of A, B. This one is the minimum of A times the minimum of B. 7, we have the maximum of the quotient A over B. We are going to maximize A and minimize B. Okay? And the minimum, no, it is the maximum, no, minimum of A over B, we minimize A and maximize B. Okay? Those are some rules that we do follow there. Those are some rules that we do follow there. Those are some rules that we do follow there. Examples. We are finding the minimum or maximum and minimum values of the following. We have one. The first one, we have 3 plus 2 cos theta. The second one, we have 1 over 2 plus 3 cos theta. The third one, we have cos theta over cos theta plus sine theta, and we have 1 over 1 plus cosec theta. So I want to look at the solution. Starting with the maximum, Roman 1, of 3 plus 2 cos theta. 3 plus 2 cos theta, 3 plus 2 cos theta. This one is the maximum of 3 plus the maximum of 2 cos theta. I think you can see that. Now, the maximum, I've used this law. The maximum of a constant is that constant. It is not affected. So I have a 3. I can pull out the 2, then times the maximum of cos theta. So it will be plus 2 into 1. Maximum of cos theta is 1. And the result you get is 5. So if you look at the minimum of that same thing, minimum of 3 plus 2 cos theta, okay? Minimum is 3 plus the minimum of 2 cos theta, which is the minimum of 3 plus 2 minimum of cos theta, okay? So this is 3 plus 2 into negative 1. The minimum of cos theta is a negative. So this is 3 minus 2, which is a 1. I think you can see the difference. One is bigger than the other. You can easily see the difference. Okay? We have, let me pick one, that is example 2. We are maximizing, let's first maximize 1 over 2 plus 3 cos theta. Okay? So if we are maximizing, we maximize the numerator and minimize the denominator. 1, no, it is a 2 plus 3 cos theta. But we have a sum in the denominator. So this is the maximum of 1 over the minimum of 2 plus the minimum of 3 cos theta. Okay? Or it is the maximum of 1 over the minimum of 2 plus 3 minimum of cos theta. So this is 1. We've said for the quotient, for the constant, its maximum minimum is not affected. And this is 2 plus 3 into negative 1. Is it? Yes. So you have 1 over 2 minus 3, which is 1 over negative 1, and this will give you a negative 1 there. It will give you a negative 1 there. Then if it is the minimum of 1 over, if it is the minimum of 1 over, if it is the minimum of 1 over 2 plus 3 cos theta, this one will be the minimum of 1 over the maximum of 2 plus 3 cos theta. Okay? So, what are we getting from there? It is 1 over, of course, the maximum of 2 is 2. Here you have a 3, giving you 1 over what? 1 over 5, giving you 1 over 5 please try out the rest. Try out the rest. We are still moving, pushing on steadily, and I want to discuss something that you people know very well. Hey, that one everybody knows, but I want to put it in a trigonometric perspective. So what we do, let's consider the right-angled triangle below. If we consider the right-angled triangle, we have to consider the right-angled triangle. That is my right-angled triangle. With an angle theta here, this is side x, that one is side y, and that is side what? R. So, first of all, cos theta is x over r. So if we make x the subject, this is r cos theta. Also, sin theta is y, that is the opposite, over the hypotenuse. If you make y the subject, that one is giving you r sin theta. Then, from Pythagoras, we have x squared plus y squared is equal to r squared. The adjacent side squared plus the opposite side squared gives you the hypotenuse side squared. Now, if this is equation 1, and this is equation 2, and this is equation 3, we can substitute substitute 1, equation 1 and 2 in 3. Okay, we are substituting 1 and 2 in 3. So my 1 is this one. If I substitute it here, I have r cos theta squared plus r sin theta squared is equal to r squared. Now, when I try to open those brackets, I have r squared cos squared theta plus r squared sin squared theta is equal to r squared. So can we divide it through? Divide it through by r squared. Divide it through by r squared. If you divide it through by r squared, you'll get cos squared theta plus sin squared theta is equal to what? Is equal to 1. You call this one equation 1. You call that one equation 1. So from equation 1, divide through by cos squared theta. If you divide through by cos squared theta, what do you get? If you divide through by cos squared theta, what do you get? You're getting, you have cos squared theta over cos squared theta plus sine squared theta over cos squared theta is equal to 1 over cos squared theta. So this one becomes 1 plus this one becomes tan squared theta is equal to sec squared theta. You call this one equation 2. You call it equation what? You call it equation 2. Still from equation 1, divide through by sine squared theta. My equation 1 is this. You have cos squared theta plus sine squared theta is equal to 1. We are dividing through by sine squared theta over sine squared theta over sine squared theta. Here, cos over sine is cot, because we are talking of reciprocals. So this one is cot squared theta plus 1 is equal to cosec squared theta. You call this one equation 3. So therefore, equations 1, 2, and 3 are called trigonometric identities. They are called trigonometric identities. Those equations 1, 2, and 3 are called trigonometric identities. Please, they are very important. We are now beginning the core of the calculus we are talking about of this trigonometry. Those equations 1, 2, and 3, that is cos squared theta plus 1, plus sine squared theta is equal to 1. They are called trigonometric what? They are called trigonometric identities. And they can be used to prove various can be used to prove other various trig identities, and also in solving various trig problems. Ig solve the following for 0 degrees less or equal to theta less or equal to 360 degrees. Roman 1, we have 2 cos squared theta plus sine theta is equal to 1. We have Roman 2, it is 5 cos theta. 5 cos theta is equal to 2 into 1 plus 2 sine squared theta. Can have 4 cot squared theta, 4 cot squared theta plus 39 is equal to 24 cosec theta. We can pick it up from there in our next lesson.